something greater than 1, let's say 2, 3. So 2 to the power of 2 is going to be positive, positive minus 1 is going to be positive, times positive. So the function will be increasing once more. يبقى إذا أنا دلوقتي عرفت الموتونيستي بتاعت الفانكشن بتاعتي. طيب I want to check for maximum and minimum. Simply I will try to get y double dash, which is going to equal to 12 x squared minus 1. Okay, let's try y from this part. Let's try y double dash at negative 1. Y double dash, the second derivative, let's see. Y double dash at positive 1 equal. If we took negative 1 and we try to substitute negative 1 to the power of 2, it's going to be positive 1. Positive 1 times 2 is going to be 12 minus 4. So it's going to give you 8, which is actually a positive. That's an x at negative. When equal to negative 1, it's right. So x at negative 1 will develop a local, okay, minimum point. طيب لو انا جيت عند 0، لو انا جيت to make a substitution in y double dash, this part will be cancelled, remaining negative 4, which is actually a negative value. Then على طول ده معناه ان الاكس قدامي في الحاله دي يبقى x equal 0. ده معناه ان انا عندي negative value. So القيمه دي هتدي لك maximum point، local maximum. لو جيت عند positive 1 هيبقى 12 minus 4. So it's gonna be positive value. يبقى اذا at x positive 1 will develop a local minimum point. تعال نجيب الفاليوز of these points. انا عارف هنا ان الاكس بتاعتي بتساوي نيجاتيف 1. الفاليو اوف واي هتبقى بكام؟ لو انا جيت حطيت اكس بتساوي نيجاتيف 1، so it's gonna be positive 4, negative 2, so it's gonna be positive 2, positive 2 plus 6, so the value here is gonna be 8. Okay, at 0, the value is gonna be 6. يبقى إذا when x equals 0، لما أجي أعمل substitution this is gonna be zeros، ده هيديني positive 6 زي ما احنا شايفين. طب لو أنا جيت عند positive 1 it's gonna be 1، it's gonna be negative 2، 1 و negative 2، so positive 1 و negative 2، so it's gonna be negative 1 و 6، it's gonna be 5. يبقى إذا at positive 1 الفاليو بتاعتي هتبقى 5. أعتقد إن القيمة اللي فوق هي كمان، شوفوا انتوا ساكتين وانا قاعد عمال اشتغل وما خدتش بالي. شوف لو انا جيت عند نيجاتيف 1، نيجاتيف 1 to the power of 4 is going to be 1، ونيجاتيف 1 is going to be 1، 1 minus 2 negative 1، so this part is going to be 5. طيب لو انا عايز اخد critical points, conflict points, all I have to do at the third step is to put y double dash equals 0. يعني اذا 12 y double dash x equal زي ما قلت equal 0، that's in 12 x squared minus 4. يعني دي معناها ان x squared will equal to 4 over 12. يعني اذا x بتساوي positive or negative 1 over root 3. At these points يحصل عندي conflict point. The curve will change its concavity from concave to convex. From all of this, I can speculate the shape of this function. لو أنا اعتبرت إن ده y axis، ده كده y axis، واللي موجود عليه دلوقتي ال x axis، ولو أنا هروح عند البوينتس دي at x equals 0، هنا x equals 0، this is the first point. At x equal positive 1, let's say here, ده positive 1. At x equal negative 1, let's see here, this is negative 1 positive 1. لو انا رحت عند الزيرو هلاقي ان الفاليو اوف y بتساوي 6. لو رحت عند نيجاتيف 1 هلاقي الفاليو اوف y المفروض انها بتساوي 5. عند البوزيتيف 1 هلاقيها انها بتساوي negative 5. This is correct. This one is supposed to be symmetric. I'm sorry for the sketch. This is positive 1. At 0, we have a maximum. So this is the function. At this part, this is the function. Minimum points. Positive 1 over root 3 is going to be here. Negative 1 over 3 is going to be here. Derivative I connect this part, so it's going to be like this. And then we'll go. This part will go like this. And then we'll go up like that. اهو ده الكيرف بتاعي. لاحظ ان from negative 1 to 0 بص زي الجدول اللي فوق الجزء ده اهو decreasing from negative 1 to 0 الجزء ده increasing from 0 to positive 1 او from 0 to positive 1 الجزء ده رجع تاني انه يبقى decreasing from 1 and up الجزء ده رجع ان هو يبقى increasing. وده الشكل بتاع الكيرف بتاعي وانا بطلع اللوكال ماكسيموم واللوكال مينيموم والمونوتونستي بتاعت الكيرف بتاعي. اتمنى ان اللوحه تبقى واضحه قدامك. You can take a photo for this, and as I told you previously, it's gonna be recorded, so you should be in a very good position. Okay يا شباب? Okay? Everything okay? Okay folks. Let me get rid of this slide. The last thing that I want to speak with you about is to make a revision for solving using grammar or evaluating a certain determinant. هنا بيقول لك just a second please. هنا برضه بيقول لك ايه؟ اهو بيقول لك هنا using grammar method, try to solve the following differential equations. 2x minus y equal 4 where x minus 3y الكلام ده equal 6 using grammar method. طيب انا عايز احل بالgrammar method. طبعا حاجه very very simple compared to what we did to what we go through. All I have to do is to rewrite this system. It's a simplest method for solving a system of equation. So I will have 2x minus y equal 4. The second one is going to be x minus 3y, which is going to equal to 6. From these two equations, I can put them on a matrix form on this pattern. So it's going to be 2, 1, negative 1, negative 3, close it, times x, y, and all of this will equal to 4 and 6. And then we say 4, then we say 6. يبقى simply this system of equation, I've succeeded in transforming it into the following matrix form. I have 2, negative 1, 1, negative 3, x, y, 4, and 6. The next step, I will try to solve this system of equation using grammar. In order to solve it using grammar, as we usually know the main steps, I will have to get the determinant of this part, and this is the determinant of the coefficient matrix, which is simply 2, negative 1, 1, and negative 3, which is going to develop 2 times negative 3, which is negative 6. بعدين يبقى negative secondary diagonal, so plus 1, this value is going to be negative 5. In a similar manner, I will try to get delta relative to x, which is simply, it will be done from the coefficient 1, negative 1, negative 3, I will replace the first column by the result column, which is 4 and 6, which is going to equal 4 times negative 3, it's going to be negative 12, plus 6, that's equal to negative 6. In a similar manner, I can get delta y which equal to same coefficient أنا بنقله تحت بالظبط أو add 2 with 1. The second column I will replace it with 4 and x, 4 and 6. This is 4 and that's x. And I will try to evaluate this determinant once more. So it's going to be 12 minus 4. So this is going to be 12 minus 4, which is going to develop 8. From these steps, I can simply find the value of x from all of this. So the x will equal to the determinant of x divided by delta as we studied before. Y will equal to the determinant of y divided by delta, which is simply all you have to do is to divide -6 or -5, and the other one, which is going to be 8 over -5. This is going to be 6 by 5. This is going to be -8 over 5. You succeeded in solving using Cramer method. Something very, very simple. As you can see, folks, it's very, very simple. It's durable, easy to handle, and it has no complications whatsoever. Perfect. Okay, let's flip this slide. The last thing I want to show to you, if you have complicated determinant, determinant complicated, let's see if I have something like this. I want to evaluate the value of this determinant. Okay, this is 3, -1, +1. This is negative question, so I will try to solve it for him. 3, as you told me in the morning, I really need to know how to deal with such a problem. It's really something very easy. It's a piece of cake, actually. I want to solve this determinant. I want to find the value of this determinant. And by solving this problem, I will come to the end of our questions today. Okay, how to solve it? The main idea in solving or to determining the value of a complicated or a huge dimension determinant is to try to develop as much as zeros possible. Try to have a lot of zeros as much as you can. Well, from the numbers, I can multiply the first row by negative and add it to the second and third. And by this way, I will have a lot of zeros. Let's try to do this. So, this is going to develop. The first row is going to be 3, 2, 4, and 1. I will try to multiply it by negative, add it on the second row, and the result I will convey to you. So, I will multiply by -1. -3 plus 3, it's going to be 0. -2 plus -1, it will equal to -3. Remark, I'm multiplying the corresponding elements and adding them together. -4 plus 1, it's going to be -3. -1 times plus 0 is going to be -1. In a similar manner, I will take the first row, multiply by negative, add it to the third one. -3 plus 3, so it's going to be 0. -2 plus 0, so it's going to be -2. -4 plus 1, it's going to be -3. -1 plus 2, so it's going to be +1. The last row will be 0, 2, 1, and 3. This is the last row. Okay, perfect. I still remember the sign rule. The sign rule of a fourth dimension determinant or determinant from was dimension 4. The sign law states that we will start with positive, negative, 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 positive, and then negative. Remark that we are walking as a zigzag. So all I have to do now is to take the first column. I will take the column or the row that contains a lot of zeros as much as possible. So I will start with 3, so it's going to be 3 times. Try to remove the first row and the first column. the remaining will be negative 3, negative 3, negative 1. Then I will have negative 2, positive 2, negative 3, 1, 1, and 3. This is the remaining part. Once you try to eliminate the first row and the first column, this is what's going to remain. The rest of the cofactors will equal to 0 because it's going to be negative 0 times something plus 0 times something, negative 0 times something. So, in a similar manner, I can add these two rows to each other. If I add the third row to the second row, I will have another 0, which is going to make your life easier or whatever you want to do. So I will say that this is going to be 3, open a bracket. This is the new determinant. Negative 3, negative 3, negative 1. 2 minus 2, it's going to be 0, 1, negative 3, it's going to be negative 2. 3, 1, it's going to be 4. This is going to be 2, 1, 3. It's enough. I will try to expand or find the value using the first column. So the value of this determinant will be 3. Open the bracket, negative 3. Eliminate the column row. You will have negative 2, 4, 1, and 3. This is 0 times negative. It's going to be 0 plus 2. Try also to eliminate the row and the column. You will end up having negative 3, negative 1, negative 2, and the 4. Close this determinant, so it's going to be 3, open the bracket. Negative 2 times 3 is going to be negative 6. Negative portion is going to be negative 10 times negative 3. So you will end up having 30. This one is going to be negative 12 plus 2, so it's going to be negative 10. Negative 10 times 2, so it's going to be negative 20. The result will be 30, as you can see. And now we succeeded in solving this problem, as you can see. So it's really very simple. You don't need anything else. It's really a very clear example for you. You can access at any time, and it's very, very simple. Thank you very much. I enjoyed being with you today. This ends the revision of level 4 engineering mathematics for semester A. Thank you very much. I appreciate the time and effort, and I hope the best for you all. Thank you very much. Enjoy your day. Thank you. Thank you very much.